up, everybody? It's time for another lesson on science, and we are fully stocked. We are ready to go. It's going to be a fun one. Things are going to get a little tricky, so you do need to be following. I'm going to add some math in here, but I think you'll definitely be fine, especially after the last unit. You will be primo. All right, make sure you say hi in the chat. Make sure I know that you're here, and if your name doesn't say your name, then let me know who you are. And let's get going. Where did I go? Here I am. Hi, everyone. So, we are looking at this today. We need to be able to describe the relationship between mass, volume, and density. Okay? We need to be able to compare the density of a variety of liquids. What's happening? So let's get going. So we touched on this on Wednesday, okay, our last lesson. If you were there live, then it was Wednesday. And if whatever you watched, you watched. Okay, we talked about the difference between mass and weight. Okay, that your mass is the same, but your weight changes on the moon. We talked about the formula for volume, because width times height. Talked about this. Okay, talked about the 3 ways to find volume, calculating it, looking at displacement, and just reading it right out of a measuring cup or graduated cylinder or beaker. Okay, we look at the calculations. So let's talk right now. What is heavier? Let me know in the chat. What is your answer? What is heavier? A pound of feathers or a pound of rocks? Tell me in the chat right now. Boom, 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 boom. What is heavier? A pound of feathers or a pound of rocks? Time's up. I assume most of you were right that neither is heavier because they're both 1 pound. Maybe your first instinct was to say the rocks are heavier, but if you have a pound of feathers, you got a pound of feathers. That was just me just trying to mess with you. But what about this? Would you rather sleep on a pillow not filled with a pound, a pillow filled with rocks, or a pillow filled with feathers? What would you have the better sleep on? I should see the chat blowing up. Bum, 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 bum. Everybody should be saying feathers. Feathers. There it is. Okay? Just imagine that would not be a comfortable sleep. Okay? Both do take up the same volume, but they have different masses. Okay? They take up the same amount of space, but they weigh a lot different. Our first question asked what was heavier, the same weight. Okay, but now we're looking a little different. Okay? Rocks are very dense. There's that word density, okay? Feathers are not very dense. So let's talk about what density is. Okay? So density, in its official definition, is a measure of the mass per unit volume of a substance. Okay, so how much it weighs, okay, per how much volume it takes up. Okay? A little confusing? So let's just go ahead with this. And let's say the tighter that the particles are packed, the greater the density. So you're looking at my picture here. Which of the two, would you say 1 or would you say 2, according to this definition, has a higher density? Which has a higher density? Tell me in the chat right now, which has a higher density? Does 1 have a higher density or does 2? And why? Okay? So, sounds like a lot of you are saying 1. Okay? The particles here that you see, these black dots, are a lot tighter. Okay? They're tighter packed. They're packed together in a tighter way. Okay. All right. And there's a lot more of a gap here in number 2, right? You can see lots of gaps. Okay, so less being packed together, so less dense. Okay? Oh, I hear you guys. Wait, no, go back. I hear you. Okay. Hopefully you are taking notes. We are in lesson 4 right now of your unit binder. Okay, make sure you are taking notes. Okay. Very important formula right here. Very, 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 very important. I'm going to put a triangle with an exclamation point in it because it is that important. Okay? Density equals the mass divided by the volume. So how much does it weigh per the amount of space it's taking up? So if you think about it, how much do the rocks in that pillowcase weigh compared to the volume that they take up? So the rocks will have a higher mass than the feathers, right? They would both be in the same volume because it's the same pillowcase. Okay, so as you do the math, the rocks will have a higher density than the feathers. Okay, let me introduce all the concepts before you figure out or decide that you're confused. Just let me introduce things, and then we'll get into this. We'll unpack this a little bit better. Okay, so in your unit binder, if you flip off of the current slide that you're on, please. Okay. So we are on this lesson, lesson 4. So you should be taking notes on this slide. Okay. Flip over to this slide. Okay. Question 4 says, what units can be used to measure density? Let's talk about that. Okay. We measure density of liquids using milliliters and liters. Okay. So we use this graduated cylinder and we record milliliters. Okay. We measure the density of solids using volume measurements, so millimeters cubed, centimeters cubed, etc., etc. Okay, so write that in. If you forget how to come on, please. If you forget how to make the exponent, looks like my computer forgot how to work. Millimeters cubed. Okay, that says millimeters 3. So we're going to go to format. We're going to go to text, and we're going to say superscript. Okay, or it's control period. And every time I press it, it does that. Okay. If you're writing in the chat, okay, or anywhere where you don't have that ability, we use this caret sign. Okay, this is shift number 6. Okay, and this tells me millimeters to the power of 3, centimeters to the power of 3. Okay, or you can go format, text, superscript. Okay, well, just a quick note there. Okay. So let's try a calculation here. Okay, let's calculate the density of cooking oil. I'll sneak down here. Hello. An empty container has a mass of 50 grams. When 75 milliliters of oil are placed in the total mass, or are placed in it, the total mass is 120 grams. Calculate the density of the oil. Okay, so let's go ahead and let's highlight our important terms. Okay, mass of 50 grams. Now, think back to our formula. Okay, especially going to be looking for these terms: density, mass, and volume. You are looking for those, or you're looking for their units. Okay, so mass, in this case, is being measured using grams. We talked about on the last slide what units you can find for volume. Okay? Okay, so 35 milliliters of oil, that would be our volume. Boom. This would be our mass, our M. Okay? Calculate the density. Okay, now you're saying to me, Mr. Stav, hold on. There's two mass measurements. Why is that? Okay, and for that, I need to go and get something. Okay, so this is going to come up a lot in some of the math that we're going to do over the next little bit. So it's important that you understand this. Okay, this question says an empty container has a mass of 50 grams. This would be the empty container. Okay, so they're measuring it pre-experiment. Before the experiment, they're telling you that this container has a mass of 50 grams. Do you think I could write on this? Boom. Okay, so it says once we've placed in this oil, okay, the mass is now 120 grams. So for my sake, let's put in water. Okay. Let's just have you didn't take it out of the water bottle. Yes. Okay. If I weigh just the water, it's going to, let's say it weighs 10 pounds. Or let's say it weighs 100 grams. If I add two things on the scale, is it going to weigh more? Okay. Very important that you're with me. I'm going to be confusing for a little bit. Okay. The water on its own weighs a certain amount. The water and the beaker weigh more. In fact, let's turn this on. Can you read the zero? Kind of. Okay, so the water alone weighs 474. And when we add in the beaker, it now goes up to 620 grams. So, would you agree that this weighs more with a beaker, with a container? Okay, so what's going to be happening is we actually do this when we weigh Paxton. Okay, because Paxton's squirmy and wormy, and he won't just stand on. This is not Paxton. This is me. Okay, he won't just. Let's make this Paxton. Paxton won't just stand on a scale and wait for me to take his measurements. Okay, so I actually have to stand on the scale and hold Paxton myself. Okay, so let's say I weigh 250 pounds, 230 pounds while holding Paxton. Could you say that Paxton weighs 230 pounds? That would be a very big baby. Okay, but what we can do mathematically, obviously, if we were just to weigh Paxton, that would be easier, but it's not possible. Okay, the same thing if I was to pour a liquid onto the scale, it wouldn't be possible. We have to contain it. Okay, so what we do as parents is we weigh me, right? And let's say I come out to be 200 pounds. And then we add Paxton into my arms. And then we check the reading. And now I'm 230 pounds. So how would I figure out how much Paxton weighs? Right, I would just subtract my weight with Paxton from my weight without Paxton. Okay, so if I weighed 200 pounds without Paxton and I weighed 230 pounds with him, I would just do 230, take away 200, and I would be left with 30 pounds. Paxton would be 30 pounds if he was there by himself. So we are going to have the same thing come up quite a bit in the upcoming questions. I'm going to give you the weight of the container by itself, empty. Okay, so in this case, this container is 146 grams. Okay, and when I add in water, okay, makes me thirsty. I now get my measurement. My reading is 391 grams. I think it's backwards for you, isn't it? Oh no. I just lost my other camera. Please hold. Back. There it is. Okay. So this is it, empty. And this is it, full. So how much did the water weigh? The water doesn't weigh 391 grams, right? Because 146 of that belongs to just the container. So we actually have to say 391, take away that weight of that empty container, okay, which is 146. Get your calculator, and you say 391, take away 146, equals 245. I assume some of you beat me to it in the chat. Well done. Using your mental math. I love it. Okay. I'd use my calculator. I'm not as smart as you guys. Okay. So let's go back to our question. Okay. Our empty container has a mass of 50 grams when 75 milliliters of oil. Here I just added, what did I add? 250 milliliters of water. Okay. But now if I add 75 milliliters of oil, the total mass is 120 grams. Okay, so let me move some stuff so I can write here. So in total, it weighs 120 grams. Okay, but we have to remove the weight of the empty container. Okay, so I type in 120, take away 50, and that leaves me with, yeah, I know you're beating me in the chat, that's awesome, 70 grams total. Okay, wow, Mr. Stav, this is getting really mathy. Yeah, and we're not even at the math yet. Okay, this is just to figure out the mass of just the fluid that we're measuring, or that we're figuring out the density of. Okay, we got to get rid of the empty container's weight. We don't want to know what it weighs. Okay, I'm 200 pounds. Paxton is 30 pounds. Together, we're 230 pounds. But we don't want to know what I weigh. We want to know what just Paxton weighs. Okay? So we've got to kind of do some pre-math. Okay? You will have lots of chances to experiment and play around with that. Okay? And what I would encourage you to do is, as you get into some of those questions, come back to me to this lesson and just replay this section over and over, because right now it's a little fresh. You're a little new into it and you're like, it's going over your head and you're like, wait, what? Okay? So let's go to our PowerPoint and look at that math. Okay? First, I have to figure out the mass. This is what we just talked about. Okay? This is it empty, according to the question. And this is it full. Oh, that was bad. That was very, very bad. Okay? So the mass is 70 grams of just the oil without that empty container. Okay? So we start with always start with our formula. Density equals mass divided by volume. Hold on, Mr. Stav, where did you get that from? You got it from here. Okay? From an earlier slide. That should be in your notes. You're going to need this a lot. Okay? Now, the math is as simple as plugging in the numbers. So the first line is we write the formula. The second line is we fill in what we know. Okay, so the mass is 70 grams. This is the mass without the empty container. Okay, and the volume that we placed in was 75 milliliters. So we do the math, and the density equals 0.93. Check this out, grams per milliliter. Grams per milliliter. This is where we get the units from. Okay, the mass is units per the volumes units. Yes, units matter. Okay. Are you with me? If you're with me in the chat, say got it, or with you, say got it, got it. I want to see the chat blow up. Got it, got it, got it, got it. Okay. If you're confused on this, immediately after this lesson, from 2 o'clock to 2:30 and 2:30 to 3, we'll be doing math help or science help, and I will help you with this math and these concepts. Okay. You can speak to me and interact with me. Okay. Every Friday we're going to do this. You have the chance to get some science help. What is this? Oh my goodness. Now, Smitty, I know you're thinking this, so I'm just going to say it. You remember last unit where we had these circles for mechanical advantage? Do you remember this? Do you remember this? And we had MA here. Oh boy, this is really bad. Then we had effort force and resistance force. Remember that? This is the exact same. I could have put this into a circle. Okay? I just decided to put it into a triangle because a lot of people use triangles instead of a circle. Now let's flip back and understand that the curriculum is asking us to understand the relationship between mass, volume, and density. Okay? So we understand that they are related. They have a relationship. Okay? One impacts the other. Okay? Density is mass per volume. Let's flip for a second to your notes. And let's talk about question 2 here. Okay? Much like with mechanical advantage, some of you are thinking, no, Mr. Stav, you said there wouldn't be as much math. No. You'll be fine. Trust me, you will be fine. Okay? Trying to figure out my left, your right. I think your volume's here. That's a B. Oh! Writing upside down is hard. I haven't done it in a month now, guys. It's been a while. Okay? So, if I can have two of these. Oh, you didn't even see that. That's good. Oh, that's useless because it's backwards. If I can have 2 out of the 3, I can figure out, I can solve. Okay, in my class we call it math murder, and everywhere else in the world they call it isolating a variable. Okay, we can solve for one. So if a question gives me volume and density, I can solve for mass. Okay, whereas if a question gives me mass and volume, like we just did in that last question, we can solve for density. Now, do you remember how this works? Let's flip my camera over to here. Now let's go to the next slide. Okay. If they are on top and bottom, mass and volume, top and bottom. Density is underneath mass. What operation is this? Okay. This is division. Okay. These are not related. Okay. If they are side by side, so volume and density are side by side, that would be multiplication. Write this down. So to solve, if a question is asking you to solve for mass, mass equals volume times density. Okay? If a question is asking you to solve for volume, okay, then it's mass divided by density. And if a question is asking you to solve for density, it would be mass divided by volume. So you can go ahead and you can memorize 3 formulas, or you can understand that they are related, okay, and that we can use them, each other, to solve for each other. So we can just remember this triangle and only have to plug numbers in, okay? Less memorizing with this strategy, okay? With that said, you'll notice that this is not in your unit binder. Okay, that's fine. You can survive without it. You can draw your own, or I was able to take the time. My mouse is stuck. Let's move me out of the way. Okay, I was able to create this for you. So you go to Mr. STAV, our Mr. STAV Google Classroom. I'm going to refresh. Mine is not showing up. You will notice that I have posted a new material density calculation slide. You're going to open that. Okay, and like always, you're going to copy it and then paste it into your unit binder. Okay? Where do I post it, Mr. STAV? Where do I paste it? Okay, so my recommendation will be after this density calculation slide, this lesson 5 slide. I would recommend pasting it right here. So this is what it looks like. It's exactly what you just saw on the slide. Okay, you see the triangle and you see the summary here. Okay, put it in there. And trust me, it will help you. It'll save you time. Okay? So I am waiting for you to do that. I should have said go. Okay, go do that. And while you do that, I am going to set up for our poem. Okay? It's Po time. Po. Predict, observe, explain. So just a recap, right now you are going to the Google Classroom and you are uploading that slide into your notes. Okay? Okay. This week you are going to complete discovering density. We're going to do that now. Okay, you'll see it's 2 slides. You're going to complete this full slide. Okay, and then you are going to complete all of these slides. Okay, lots of math to do. Okay, so let's look at one of these. Here it says calculate the volume of a liquid that has a density of 5.45 grams per milliliter and a mass of 65 grams. Okay, so we flip up here and we're trying to solve for what? Oh, I forget. It says calculate the volume. Calculate the volume. So I am solving for volume here. So that means it's going to be mass divided by density. Okay, so let's come back. I'm going to start with my formula. I'm going to say volume equals mass divided by density. I didn't mean to make it a capital. Okay. I'm just going to go back and make sure that my formula is right. Actually, I'm just going to do that so I can keep it there. Volume equals mass over density. Perfect. I am happy about that. Second line, I'm going to copy in my numbers. So what is the mass? Okay. Oh, I'm writing in the wrong one. Thanks for telling me that, chat. There we go. Okay, so the volume equals mass. What is mass? Volume with a density of, no, I want mass. And a mass of 65 grams. So we're going to go 65 divided by, or you can use the fancy divided by sign, okay, by the density, which is 5.45. Okay, so I'm going to write that in, 5.45. Then get my math number device thingy. 65 divided by 5.45 and equals this kind of absurd number. Okay, so I'm going to the next line. Volume equals 119.926. What do you think my units are? How would I know what my volume units are? Tell me in the chat. How do I know what my units are? Okay, you got to go back to the question, right? So gram is a mass measurement or unit. So over here, a density is the mass per volume. So here's our volume measurement right here, right built into the question. They give you the answer. Okay, so it's 119.9, so essentially 120 milliliters. Okay, so I'm going to put my final answer in here. Just what if I don't want to round? But don't round. 119.9. Okay. So you see some of these are calculate the mass. Some of them are calculate the volume. Okay. Some of them are calculate the density. Okay. Some of these are going to ask you to calculate displacement first. You need to go back to my lesson, our previous lesson, go back to that video, watch that video again. Look at this, displaces. Okay, so you're gonna have to calculate displacement to figure out volume. Okay, some of them will say that a graduated cylinder has a mass of 50 grams when empty. So you're gonna have to calculate, just like that Paxton scenario, that analogy, you have to calculate it without the weight of the empty glass. Okay, so there's a couple of steps first. This is a common misconception. I imagine that people will be asking this at our science help. So join us and I'll help you. Okay. This one is kind of fun. Okay. You're going to solve these. Okay. Then you'll notice mine says start with the formula here, show your calculations here. Yours doesn't because of Google. It says click the add text. So I wrote this here, type the formula here, show your work here. Okay. Once you figure out which one is what their densities are, then come down here and notice the color. Okay. Let's say fluid A is the most dense, then it's going to be at the very bottom. And then let's say C was the next dense. I honestly don't remember, so don't copy me, but okay. Now that's kind of confusing, and I'll explain that in our PO now. Okay, the last one here is you are going to follow the question, okay, to figure out what the mystery objects are. So you're going to do the formula, you're going to figure out the answer, and if your answer, let's say, is 21.4, you're going to come to this table of densities. You're going to see which one has a density of 21.4. Oh, here it is, platinum. So my mystery object, you're going to type this in here. Mystery object is platinum. Mr. Stav, you're going too fast. You're confusing me. That's okay. I will see you at Science Help. We'll get this all sorted out. You will be fine. Okay? So, now, let's talk about what I was referring to here. So to do that, we need to do our PO. So we need some PO music. Yeah. Okay, we are going to do the PO, discovering density. Okay? We are actually going to pour a bunch of fluids. It's in the way. Okay, we're going to pour 15 milliliters of each of these fluids into this glass little cylinder. Okay? The reason it's glass is so that you can see it. I was supposed to use a graduated cylinder, but our school ones are too foggy. I couldn't see through, so I moved to this. Okay? So, what I would like you to do is understand that because of their densities, they're not going to mix. Right? Normally, if you add certain fluids, they mix. But these ones are actually going to stack. Okay? They're going to stack on top of each other. And what I would like you to do is predict in what order will they stack? Who will be at the bottom? Who will be at the top? Okay? So what are we going to use? That's where we come to this. We are going to be pouring honey in, dish soap, water, corn syrup, vegetable oil, and rubbing alcohol. Now, I didn't have rubbing alcohol at my house. And because of COVID, I can't go out and get some. So instead, I took Kirby's nail polish remover. Okay? So here's our dish soap. And I filled this with 50 milliliters, and that's just so we pour an equal amount of each fluid into the glass. Now we are doing soap. We're doing olive oil. What did I do? I lost it. Oh, No, I didn't. Over here. I'm using Aunt Jemima's maple syrup because I did not have corn syrup at the house. Okay, that is still in the classroom, and I forgot to bring that home. And I'm not going to the grocery store to get some. Okay, I am using honey, and like I said, nail polish remover. And what I did to save time was I pre-poured them because that would be boring to watch. But since some of you want to see everything, I'll show you the art of pouring. Get down to eye level. I know that I need a little bit more. That's good right there. Now, we do have a problem because water is the same color as the rubbing off, or as the nail polish remover. Okay, so what I'm going to do, I don't want to mess this up. I'm going to use food coloring because it won't change its density. And I'm going to put a couple drops into the nail polish remover. And put a couple drops into the water. Mix it around. Now I will forget, so maybe in the chat somebody can help me remember, or maybe in your notes you're going to write this down. The nail polish remover is the pink, and the water is blue. So I'm just here mixing it. Okay. The soap is green. The cooking oil, the vegetable oil, is yellow, and the syrup it's brown, syrupy color. Together they look like the Power Rangers. It's morphin' time. Okay. So I would like you to make a prediction. Which will be at the very bottom? Oh, we'll also have honey. I forgot about honey. I didn't pour honey into a beaker because it's just going to make a mess for me to clean up, and I don't really want to. So, it's just that that's not good science. I know. I apologize. Now, because this is a science experiment, let's goggle up. Let's be safe. Here we go. I'm going to use this soup can just simply to boost our container, which I lost. I lost it. There we go. There we go. Also, when pouring the honey, I want the better spout to pour it from. Here we go. Think about the honey's density. Think about how thick it is. Okay, just getting my notes so I do this right. Let's go with the maple syrup next. Other. Okay, Hopefully this is distinguishable enough. There we go. Pouring the syrup on top, and it is impossible to see the difference right now. Okay, I poured the honey. Can I get this any closer to the camera? I know it'll do. Here we go. Okay, so you can already see that there's a difference. That's the honey, and you'll notice it hasn't mixed. Okay, so we have the syrup, the darker color. The honey is the lighter, the brighter color. Sure, all my light. Perfect. All right. What do we want to do next? Let's do the dish soap. Here we go. The green dish soap. That is 15 milliliters of dish soap. And I'm going to be careful not to shake it or mix it. We get nice and close. Look at the layers. Ooh. Oof. That is beautiful. Okay. We are going to go next. Let's do water. Which one was the water? That's right, it was the blue one. I'm actually going to use this turkey baster to help me. See if I can get any more out of this. Got quite a bit more out of it. Okay. Let's bring it close. Look at the layers forming. Perfect layers. Okay. Next, let us do cooking oil. Booyakasha. Bazinga. Again, another layer is formed. Okay. One more left, and that is what? What is that? Okay. It is our nail polish remover. I'm just cleaning out the base there a little bit. Remember, we made it purple. Okay. Can definitely smell it over here. Let me turn this. Look at those layers. Use my phone to give you some backlight. Really helps. Okay, write in your observations. Okay, layer 1 is honey. Then we have the maple syrup. Then we have the dish soap. Then we have the water. Then we have the vegetable oil. Then we have the nail polish remover. Write in your observations. Now I want to do one other thing that's kind of neat. And I want to drop some items in. Items that have different densities. All right, let me get my hand. So I'm going to drop in the lid from our water bottle, a dice, beads that I stole from Everly's Art Center, a screw or a bolt from an IKEA piece of furniture. I don't know why I had it extras. That's weird. A couple of popcorn kernels. Okay, I'll drop one at a time. And a little tomato. Okay, there we go. I'm going to drop, I don't know, drop the bolt in. Now let's drop a popcorn kernel. Here we go. Popcorn kernel. Dropping into our solution. 3, 2, 1, go. Who knows where it went? There it is. Do you see where it stops? Write that down. What did the kernel stop? What layer? There it is, right in the maple syrup. Okay, let's drop one of Everly's art beads. Where did it stop? In the water. Interesting. Fascinating. Look at it sitting there. Oh, it's sunken a little bit. It's dropped from the water to the dish soap. The bead, this is the art bead, is now in the dish soap. Okay, let's drop our next item. How about the bolt? Where do you think the bolt? Make your predictions right now. Tell me in the chat. What layer do you think the bolt is going to stop at? Okay. What do you think the density of this bolt is? Okay, here we go. Boom. That sank like a rock. That went straight to the bottom. Make your observations. Isn't it neat how the different density of the fluids is stopping the different items of different density? So the popcorn kernel went to the second to the bottom layer. The art bead went to the third to the bottom. The bolt went right to the bottom. Where do you think the dice? What about the dice? Which layer? Tell me in the chat. Which layer do you think will stop, or will the dice go all the way to the bottom? If you're wondering, yes, this is a pain in the butt to clean up after. Here we go. Dropping the dice. In 3, 2, 1, go. There she goes. Ah. Pretty too far now. Make your observations, write them down. All right. I have the cherry tomato, the baby tomato. Where do you think that's dropping to? What's cool is it muddies up for a little bit and then it all kind of figures itself out. You can't see it at all. There it is. Do you see it in the dish soap? It's sitting on top of the maple syrup. It won't go in the maple syrup. It's sitting on top of the maple syrup in the dish soap. It's displacing the dish soap. This is the highest that the green has ever been. There's the tomato. There's the bowl. The art bead. And where's the kernel? There's the kernel. Hi, kernel. Okay. Let's use this now. What layer do you think this is going to stop at? I'm going to drop it this way, not flat. I'm going to drop it this way. Here we go. Oh, that was a fail. I missed it. Hey, there it goes. Okay, you can't really see it that well. But it is sitting in the nail polish remover on top of the vegetable oil. Sorry, that one was lame to see. I also have a paper clip. So I might as well drop it because we got it. I don't know why I'm doing that to the camera. Where do you think paper clip's going to go? Here we go. Where did it go? Where did it go? Whoa, snap. There he is. I think a lot of you were wrong. That paper clip went all the way to our bottom layer. But interestingly enough, it is not at the bottom. And now it's going to the bottom. There you have it, my friends. The different densities. First of all, it's just cool that they don't layer, that they don't mix. Okay? Then it's cool to see where these things drop and don't drop, where they stop. So, that is our Poe. What I would like you to do now is go to this slide, and I would like you to put them in order, as if you needed this on your test. Sorry, I got a little something there. So the honey was at the very bottom. Then what came next? Okay, the maple syrup. We didn't have maple. You could change the name to corn, from corn syrup to maple syrup. You just double click on corn, where you type in maple. Okay. So rearrange those. You could change the name from rubbing alcohol to nail polish remover. Okay. So place those in order. Okay, do that now. Okay, so I'm gonna post this up now to close off our lesson because I got to get to guided groups. Okay, so what's going on here is the particles in the honey are so packed together. Okay, their particles are tighter than that of the maple syrup or corn syrup. Okay, so we say that honey is more dense than maple syrup. Okay? Maple syrup does not readily mix with honey because the different densities that they have. Okay, and so for each layer on top, not taupe, change that. Okay, The lower layers have higher densities, so these are the higher densities, and these are the lower densities up high. Okay, so you have a lot of slides to do. Okay, don't tell your parents you don't have work. You got lots of work. You should have every slide all the way up until buoyancy done. Okay, this is a lot of work. There's a lot here for you to do. Shouldn't take you that long, however. Okay, you need to finish this poem. Were your predictions correct? What was incorrect? And explain what you know about density. Okay, you can always go back to this lesson and pause that last screen to help you answer these questions. So, I hope you enjoyed this lesson. The reason why it's so long is because the poem was quite tricky. Okay, it took about 30 minutes just to do the poem. So, with that said, I will see you at Guided, and be awesome today.